Hello friends, welcome to Unacademy, which is the largest online education platform for GATE Computer Science and Information Technology. Myself, Malisham Devasani. In this session, I will be discussing very important topic, which is the conversion from NFA to DFA and the minimization of DFA. So let's look at how we can do conversion from NFA to DFA first, then we will go for the minimization of DFA. Yeah, before starting the actual topic, let me introduce myself. Guys, I have secured all year rank 119 and 210. Of course, I have also secured the other ranks which are less than this, but these two ranks I have secured during my BTech. And after that, I have written 3 times GATE, almost 4 times GATE after this 2 times. And even I got the better rank, but I want to show the rank which I have secured during my BTech. That is a 4th year and 3rd year. I have secured these ranks without any coaching support. And then I have joined MTech from IIT Bombay. I have completed MTech from IIT Bombay. Now I have almost more than 12 years of teaching experience. Now I'm teaching here TOC compiler programming on this channel. And you may remember this referral code to refer to your friends, or you may join using DEVALIVE. Is my referral code to get 10% discount, as well as this is an entry to every subject in your computer science GATE syllabus, guys. It's not just for my courses. If you are using my code, you will get my support to crack the GATE. That's mainly guidance. You can also use any referral code from any educator, but if you need my guidance, then definitely you can use this referral code and let me know, then we will crack GATE exam. And you see that there are many classes that I take on Unacademy which are completely free, and come to visit this profile unacademy.com/DevaGateCSE and log in, and you can access freely all these classes. More than near 370 classes. So far I have taken more than 370 classes are freely accessible to you, and those classes are based on some GATE combined subject quizzes and some 4 subjects and 6 subjects. I have taken the combination of the subjects separate sessions, as well as C, TOC compiler algorithm separate classes, and revision on TOC, CD and C programming, like all-in-one series on TOC, and practice sessions on almost main subjects, and guidance classes for the GATE preparation, and daily practice problems for like C programming, TOC, algorithms, and also compiler, and PYQ sessions on some subjects that I've already taken, and free test series on GATE Computer Science and IT. So these are all courses, all classes that I have taken on Unacademy which are completely free. But in case if you want to prepare the GATE exam in structured manner, and you want to guarantee your GATE rank, and you want to prepare with confidence, then you require to take the subscription, which could be Plus or Iconic subscription. Here what do you see? You will see completely structured courses. The structured courses are not at all free, and if you want to learn these structured courses like complete course on TOC practice course, and similarly C programming, compiler design, and soon I'm going to start the fast track course on TOC, where I'm going to complete the whole TOC in less time, but you will have every detail that I do basically, but here including practice. Now, what are the benefits if you join Unacademy? That Plus and Iconic, there are 2 subscriptions. You have almost all the benefits for Plus and Iconic, but Iconic have more advantages than the Plus. What? You will have a dedicated coach, live interaction, personal live interaction with educators that will boost your confidence. You can clear your doubts, and you can guarantee to motivate yourself with the kind of interaction that you will have with their educators. And you will have separate study material and booster sessions and separate study plan, personalized test analysis, and these are additional benefits for Iconic. And if you look at the prices, and Plus, I'm talking about the Plus for 1 year, 1.5 year, 2 years, and use my referral code to see that amount 27,225 for 1 year, 34,650 for 1.5 year, 39,600 for 2 years. An Iconic plan, which is a more popular and which will help you to guarantee your exam preparation with full of confidence. That is for 1 year and 2 years you will have 45,225 and 66,600. And guys, so, and then you can understand how we can how you can prepare. You can prepare through our YouTube free classes, or you can prepare with Unacademy special classes, and you can also prepare with Unacademy paid classes. You require to decide what is suitable for you. And definitely that, if you are not able to pay, and we are already guiding you, we are already helping you, and definitely this is also going to be benefited. You are already self-motivated and you are able to understand our classes, each and every concept that we discuss. That's great, but you require the more than what you are learning from us, that is the live interaction, and you require doubt clarification, you require some kind of additional practice that you will get to the paid courses. So that's what I'm talking about. Yeah, guys. Yeah, good evening, Sandeep. Good evening. And this is our Facebook group. You can join GATE Aspirants Facebook group. And we are also having the Unacademy GATE CS channel, which is for complete computer science. And you can follow all classes from all educators. So this is going to be beneficial for you guys. And also I have personal Telegram channel, but you can ask personally what is my channel to subscribe. If you want to learn from me separately, then we also have a separate channels, but that will be guiding later on. Okay, fine guys. And these are various free YouTube channels from Unacademy. Not only for computer science, you also have electrical, electronics, instrumentation, mechanical, civil, and Telugu GATE, and SSC JEE, and GATE questions for every branch, and electrical junction, and Pathshala, and RRB SSC. So you can refer these free YouTube channels with your friends to learn from us. And we have very good pool of educators on this channel, like Khalil sir, and Vishwadeep sir, and myself, and Satish sir, and Pallav sir, and Pankaj sir, and Arun sir. We are all here to teach you all the subjects from GATE Computer Science. And definitely this channel is the best for you, and we have a very good experience in teaching and taking the classes. You can ask any doubt, but you also visit Unacademy to interact with us, so you will get more benefited. Come on guys, and please like the session, and subscribe if you have not done, and share. Yes, Vaibhav Gupta, thank you so much for understanding my hard work. And definitely guys, I'm doing the hard work. The reason is I'm also like you. I was worried about the preparation during my BTech, and I failed and succeeded. And because of that, I'm trying to guide the students in right direction, so that you will not waste your time. Whatever I'm trying to speak, it is not for my beneficial, right? What I'm taking here is a more number of hours, more number of classes, and these all are going to benefit you. I just don't want to teach the popularity for anybody. Here we are trying to benefit to the students so that we get popularity. So this is what we are training to the students. We are training the students to help the students so that we get benefited from the students. Here we are not teaching to get the beneficial only for ourselves. Unacademy is going to be benefited when we guide the students in very well manner. So here on this channel, we are really very hardworking. At the same time, we are aiming to help you in right direction. Whether we teach on YouTube or we teach on Unacademy, the one thing is we are trying to help you, we are trying to guide you, and we are always there for you. But you decide how do you want to prepare with us. We are trying to guide you in right manner. Yeah, good evening, Shubhasri. Thank you so much for attending all classes, and keep following and keep learning from us, and happy to follow all of these classes. And also we request one thing, please share these videos with your friends, so that the popularity automatically comes from you basically. Thank you so much guys. Let's begin our session. Yeah, if anybody not like this session, please do that. Now we have seen in the previous sessions of the TOC, we have completed regular expressions and introduction to finite automata and finite automata construction. Guys, you may not believe me, whether I teach TOC on YouTube or Unacademy. If I am going to teach the TOC hundreds of times, I may teach the subject a different ways. So that is the reason, if even though you have learned from me, it looks like I am trying to teach something different than the previous sessions. So keep following if you want to learn the subject, because I don't teach the same subject same way all the time. Okay, all right. So now in this session, my focus is on conversion from NFA to DFA. Then once we understand, we will go for minimization of DFA. Then we will have a connection with the minimization, that is how to find equivalence classes for a given regular language. So these are the three topics in this session I have planned for you. Let's begin the first one. How to convert NFA to DFA. How to convert NFA to DFA. And guys, I am trying to help you NFA without epsilon moves. And later on in miscellaneous topics, I am going to help you how to convert with epsilon moves, also how to convert into DFA. So the idea is I have, let's say, here I have Q states and sigma alphabet, that sigma is alphabet. Let's say delta N means NFA machine, and you have an initial state Q naught and final state of NFA. Let's say this is Fn. And how do you convert? This is given to you. This is given to you. Now we have to find what is DFA. What is DFA for this given NFA? Right. What we do here, this algorithm is called as subset construction. What is the name of this? Subset construction. I'm going to construct using the subset knowledge. And guys, you must know what is a subset. And most of the people may or may not aware. Suppose let's say I have X is equal to A, B, C. Then what are the subsets possible for X? You will have empty set, or only A, or only B, or only C, or you may have A comma B and A or C, or B or C, or you will have A or B or C. These are the subsets. Total 8 subsets, 8 possible. That means 2 power 3 possible subsets are there total. So what we do here, in the subset construction, if our Q is A comma B, there are 2 states. Then we will build a DFA. This is NFA for us. We will build a DFA with maximum of 2 power Q states. Like you have pi, that is empty set, and you will have A, and you will have B, and you will have A comma B. So we have the 4 possible states. Here this one is called as a state. 4 states possible here, maximum. Here we have 2 states. So 2 states NFA, we will convert the 4 states possible in DFA. We will show that algorithm. 4 states DFA we are going to show. But actual minimum DFA could be less than 4 or equal to 4. Really we don't know. Right? The algorithm will decide whether the minimum DFA will have 4 or less than 4. We have minimization algorithm today itself. Okay, let's begin. Have you understood? Don't confuse this Q and 2 power Q. And some people have the confusion here. Guys, delta is Q cross sigma derives Q, and delta is Q cross sigma union epsilon 2 power Q. This 2 power Q is different. This is the definition of NFA. No relation between this 2 power Q and that 2 power Q. This is the definition of NFA. This is the definition of DFA. So do not involve this 2 power Q in that algorithm. I have seen some students, they keep on asking, sir, what is the difference between this 2 power Q, that 2 power Q? This 2 power Q is the possibilities of the covering transition from every state for every input symbol in the machine. Right? This is the NFA definition. This NFA definition is going to follow how to cover the transition. Okay, so don't compare this 2 power Q. Okay, what I am trying to say, look at that. Look at that. Suppose Q is equal A comma B. It means I have A, B, there are states in NFA. And 2 power Q means I have pi and A and B, and there is a set AB. Here the states are empty set, and there is A, there is B, There is A comma B. These are called as states in DFA. This is the concept between the NFA to DFA conversion. So we are going to convert NFA to DFA with the help of subsets. So we call, that is the reason, subset construction. The conversion from NFA to DFA is called as subset construction. If there are n states here, you can construct here using less than or equal to power n states. Always we can design a DFA with 2 power n states, but in minimum DFA you may have either 2 power n or less than 2 power n, because all the subsets may not be useful in minimum DFA. But in DFA you can always construct with 2 power n. So I will talk about that theoretical point slowly, guys. So I'm going to do that something like this. This one I will convert to 2 power q is my set of states in the DFA, and this is set of states in NFA. This is given to you, and sigma same delta is going to be computed, and you will see that q naught is going to be the same, but we will keep in the set. Initial state of the DFA is same and final states is going to be different. So how to compute this DFA, how to construct this DFA with the help of given NFA, we are going to see one by one, right? So what is delta D here? That is very important, guys. What is delta D? What is delta D? Delta D, I'm assuming, guys, suppose you have a set like, P comma Q. That is a subset. Assume 2 element subset. And you are covering the transition for input I, let's say. Then the meaning of this one is equal to, in NFA, you have to compute P comma I union in NFA Q comma I. That you are going to do. This is the DFA transition definition with the help of NFA transitions. Right? How do you compute the transition of a DFA? This is how we do it. This is how we do it. In the set, if you have 1 state, then we will directly take as it is, copy paste. If you have 3 states, we will do the union of the corresponding transitions. Okay, let's see. Now we have an example, guys. We have an example how to convert NFA to DFA. Now look at, guys. Here Q is Q0, Q1 and Q2. And Fn is, we have only Q1. Initial state is same. The Q0 is a Q0, no change here. And delta D is, delta N is given to you. This is a delta N. Whole machine has delta N transitions. From Q0 or A, what do you do? And basically you can build delta N very quickly, guys. Okay, let me help you. You can build the delta N table. Table is very quick to understand. On A and B, we have Q0. In algorithms, the better to use the table. Q1 is the final state. Now let's give a transition very quickly. Q0 on A. I can go to Q0, or I can go to Q1, or I can go to Q2, guys. There are 3 possible transitions. You can see that self loop on Q0, Q0 on A, and Q0 on A you can go to Q1, Q0 on A you can go to Q2, and on B you don't have anything, so fine. And Q1 on A, you can see that Q1 on A no transition, so fine. Q1 on B, self loop is there, so Q1. And Q2 on A, no transition. Q2 on B, Q1. Guys, this is the definition, that is Q cross sigma union epsilon to 2 power Q. This 2 power Q is the transition. What will be the next state? That depends on the entry of the table. Entry of the table is the element of 2 power Q, element of power set of Q, right? This is the definition of NFA. Now, how do you convert into DFA? We are going to look at, guys, now carefully look at it. How do I design? Look at that. And I have 3 states, means I will have 8 states now. I will have 8 states. So I'm going to create 8 rows somehow. Blindly, this is a blind concept. I'm doing it now. Whatever I am doing, it's a blind concept. I don't worry much about the machine. I'll copy paste. Here you have A and B, and I'm going to take the subsets now. This is the delta D table. Delta D table. Initial state is the same, so I'll put a Q0 as a set, and you will have a Q1. Okay. Instead of that, I'll just blindly copy all the subsets. What is that? Empty set and Q0. One element subsets Q2. Okay, then two element subsets Q0 Q1 and Q0 Q2, and you will have Q1 Q2, and then you will have Q0 Q1 Q2. I copied 8 subsets into 8 rows. This is what we call subset construction. Everybody? Yes. Clear this point so far? Okay, now initial state is already defined, so Q0 is initial state. Q0 is initial state, and final state is nothing but the Q1. If it present in any subset, that will become final. Now look at Q1 is present in this set, and in this subset, and in this subset. So all these subsets you are going to make a final wherever the final state of NFA present. So initial state is clear, final state is clear. And now what is the transition? I just told you guys the definition of QD. QD is going to just combine. Suppose empty set is there. Now empty set, in that there is no state, so we will write a pi only. We will write a pi only. No need to look at your machine. Now Q0 means copy the Q0 row of the NFA as it is. So you will get Q0, Q1, Q2, because I am copying the row as it is, this row, and pi. And now Q1, copy the Q1 row as it is, because the one, right, it's just like delta D of Q0 comma A means you will say just delta N of Q0 comma A. Copy paste. Okay. Now Q2 is also copy the row as it is. Now you have a difference. What difference? Q0 Q1, in the sense delta D of, you want to compute Q0 comma Q1 on A, then just you need to do the union in the NFA. That is Q0 comma A union Q1 comma A. That means we are going to combine these two. So when you do the combine of that two rows, then here you will get Q0 Q1 Q2 as a state. And next do the union. For B, do the union. Pi union Q1 is a Q1. Similarly, Q0 Q2, guys. Similarly, you will do the union for these two. Q0 Q2, these two. Then you will get Q0 Q1 Q2 union with pi. And pi union Q1 is the Q1 again. And similarly, you will have after this Q1 Q2. So do the union of these two, pi, and then Q1 union Q1. Then finally you will have all the three union, guys. Q0 Q1 Q2 and pi union Q1 is union Q1. That's a Q1. Now this is your DFA now. Guys. And you can construct as a diagram if you want, but here this DFA always takes 2 power n states. No matter what your NFA is, the DFA always exists. If anybody asks NFA with n states, we can always construct a DFA. With the 2 power n states. In the sense, I can use more than 2 power n states also if I want to, but I using algorithm. And this is the first point. So second point, if anybody asks how many states in minimum DFA, the number of states in minimum DFA has to be either 2 power n if it is already minimum, otherwise it could be less than. Minimum DFA will be less than or equal to 2 power n. And that's what we are going to learn now, guys. Is this clear? Because already you have a DFA with 2 power n, either this will be minimum or less than this, because some of the states may be useless, so we can delete them. And we have another concept to design the DFA. Why are you taking all these subsets? Sometimes all may not be required. Then let's look at how to design another way. How to design another way, guys. Now look at same example, but I don't design the same way now. Look at what I do now, guys. Now look at what I do now. Okay, for safe side, I'll keep the same delta n motion before designing, guys. Okay, let me take that very quickly. Okay, we have a Q0, Q1 and Q2. Okay, let's fill up this row, this table quickly. Fine, guys. So this is the delta n table. Like same diagram, I'm trying to make a table for you to have, now you can easily understand how to convert. Now Q0 on A, just now we have seen that it is Q0 or Q1 or Q2. Q0 on B, we don't have anything. Q1 on A, yes, we don't have anything. Q1 on A, but Q1 on B, you have Q1 itself. And Q2 on A, we don't have anything. Q2 on B, we have Q1. Now look at, guys. Now I'm going to consider the table some other way. Now some other way. Now I don't want to design randomly. I may not need all the 2 power n states. Then why are you wasting your time to write all the 2 power n states? Right? So we can do some other way. Now I'm trying to do from the beginning, guys. Let's start. I will start from initial state only. I will start from initial state, that is Q0. Q0 will tell what are the states are reachable. Maybe you will get the good DFA, and later on minimization will save your time. And instead of applying minimization algorithm on 8 states, you can apply on few states. It will work very quickly. Yes. Now Q0 on A. Look at that, copy paste. Now previous algorithm, look at that. Previously I have taken all the 8 states. I copy paste of the rows, right? By doing the union. Now I don't do that way. Now I will start from Q0 because initial state of DFA is same as initial state of NFA. So I copy paste the row of NFA because I am looking at only Q0 state. Then it has to be exactly same. Now after that, guys, now I don't take anything. I will take only what I need. I need Q0, Q1, Q2. This is the set. And this is also state of DFA. And this state on A, I will combine all the 3 rows. You will get here Q0, Q1, Q2. When I combine all the 3 rows, I will get Q1 on B. Now this is completed. Now complete 5. Pi means you will say pi because it's just like a dead state in DFA, guys. And now this is already covered. This is the same row, and Q1 I require to cover now. Q1, copy the Q1 row. Q1 on A is a pi and Q1 on B is a Q1. Now look at, is that every entry covered or not? Okay, these are only reachable states, guys. Out of 8 states, all the remaining 4 states are unreachable. So this is the algorithm for complete DFA. The previous algorithm, we are not guaranteed we will get always complete. Yes. So now only 4 states, but don't assume it is a minimum DFA. Minimum DFA could be 2 or 3. We don't know. This is the best one where all useless states are deleted in this concept. Right? We don't believe this is a minimum DFA. Remember that point. Minimum DFA could be less than or equal to this. This is the DFA best algorithm. You can always design a DFA with less than or equal to 2 power n states, which is the minimum DFA I'm talking about. So anyhow, now we have saved a lot of time to apply the minimization. If you know the minimization algorithm, you can apply on 4 states. You can take within a minute. You can convert within a minute. All right. Now final states. Q1 is the final in NFA. So make this is the final and this is the final because you can see Q1 there, right? So whichever the subset has a Q1, make that state as the final. That's all. This is the final DFA, guys. This is the final DFA. Now how easy it is, just 4 states we have. Now you can rename if you want. Somebody can rename, guys, this one. Q0. I can rename as, let's say, capital A. Then wherever you see Q naught, just make capital. There is no Q naught, right? So it's over. Now I'm renaming this set is a capital B. Then put a capital B there. Put a capital B there. And wherever you see, put a capital B there. So these three places I'm going to put a capital B. Here B is there, here B is there. Now empty set I'm going to put, let's say, C. So this all of them I'm going to put a C. You can rename now. Now remaining, that's only Q1 left, that I'm going to put a capital D. That's all. Now this is your machine, guys. Now you can draw the machine if you want to look at it, right? Somebody can draw, like, you have A, and on small a you go to B, then on small b you go to C, and B row on A self loop, on B you go to D, and C on A self loop, B also self loop, D on A is going to C, D on B self loop. Now who are the finals? The B and the D. So make these two are final. Over. Now this is your DFA, guys. Right? You can convert this to DFA. How easy it looks like now. Is it clear? So this is how you convert the NFA to DFA. And you don't know this is the minimum DFA. So if you have the knowledge of the minimization, you can say it is minimum or not. So you will apply the minimization algorithm on this. So finally, you will get either 4 states or 3 or 2 or 1. That depends on the machine. Is that clear? So don't say it is a minimum DFA. This may or may not be minimum. So minimization algorithm you need to apply. Right? If you have a knowledge of minimum DFA, you can think about it, it's a minimum or not. All right. Let's move. Now we have another example. Quickly, I'm trying to design, guys. So first, what you do, make delta n table, that's NFA table, which is very easy to apply. So A is initial, B is the final. So take it. And A on 0 pi, A on 1 you are going to B on 0 is the B itself, B on 1 pi. So you are going to make delta n table, D table. What is the delta D table? You start from same state as initial state. That the initial state of NFA will become initial state of DFA. And copy paste A row, that's empty set, and B. And empty is the new, so keep empty. This is always same, guys. For empty set, you will have the entries empty set only because it's a dead state. And B, you copy the B row. Then you will have B pi. All the states are covered. You don't need A comma B state here. So now final state, wherever you see the B, put as a final. Now we got a DFA. This is just all DFA it is. No need to write all 2 power n states, which will waste your time. Yes, this is your DFA, guys. You can now rename the states if you want it, because here every state of DFA, is subset of set of states of NFA. Remember that point. Subset of the set of states of NFA. The set of states nothing but Q. Subset of Q. If you say Q is equal to A comma B, then every state is going to be belongs to power set of Q. You can say subset of Q, you can say, or belongs to power set of Q. Both are same. Okay. Now next, guys, I hope you understood the point. So remember here, if NFA has n states, that is Q is equal to n, then definitely the minimum DFA that I'm going to show you, but anyhow DFA I have it. So you will have less than or equal to 2 power n states, because I'm going to take the help of 2 power q. You may use all 2 power q, or you may use some of the 2 power q elements. Is that clear? Less than at most 2 power n states, you can say. At most 2 power n states in minimum DFA, because we have already proved that DFA with 2 power n states exist. Clear? This was a 3 times gate question, and which is very easy to answer. Now, I hope you understood how to minimize the given how to convert given NFA to DFA. Now let's come to the point. Now we have a very important session, how to minimize the given DFA. And in the exam, we always try to construct directly minimum DFA, but sometimes they might give you a DFA. Now they wanted to answer how many states are there in the equivalent minimum DFA. Then this algorithm might help you, because sometimes you don't understand what they have given. Then don't try to understand. Just apply the algorithm, you will get the minimum DFA. So this is when you require, if already they have given a DFA and they want equivalent DFA, how many states? For given DFA with n states, they may ask how many states in equivalent minimum DFA. Then definitely less than or equal to n, but you need to understand how many. Is it n or n minus 1, n minus 2? The particular example will tell us. Is that clear? This is what we are going to do. I have n states. Now I want to look at, are there any few states can be combined or not? Okay, now let's start. How to say two states are equivalent? What is the use of equivalent states? If we have equivalent states, we can combine them. If we have equivalent states, then we can combine them. We can merge, we can combine into a single state. We can do that. Example, suppose I have A on B. Let's say here I have a final state A comma B. Here I have a final state A comma B. Now guys, if you look at this diagram, what the capital B and C are doing? Here B and C are actually equivalent. You can combine them. How do you know that equivalent? You need to know the definition. Here B and C are equivalent, so you can combine as a single state. We can combine it because the job of B and C, both are final, both are doing same thing, that is on A and B they are always accepting. We can combine this. So you may get the diagram like, we may get diagram like this, A on A comma B, we can get BC as a single state. Then what is the equivalent definition? What is equivalent definition? That's a difficult point here, guys. That is a difficult point. I'm going to talk about that. And how to say two states are distinguishable? You look at capital A and capital B. Both are distinguishable. You cannot combine. Then if we have two distinguishable states, we should never combine them. If we have distinguishable, you have distinguished them, we cannot combine. If we have distinguishable states, then we cannot combine ever. We should not combine. We should not combine them. We should not combine. This is what we have. Then what is the definition of equivalence? What is the definition of distinguishable? Let me write them, guys. Let me write them. Okay, let P and Q be equivalent states. These two are equivalent states. Okay, so I'm assuming that P and Q are equivalent states. Then when is that possible? If and only if for all strings belongs to sigma star, if you read any string from P and any string from Q, both should go to, both must halt at, both are finals or both are non-finals. It means from P, if I read a W, if you go to final, then Q on the same string, you should go to final. Or If P on W goes to non-final, it's not for one W, I'm talking about every W, then only we can combine, guys. Then only we can combine. That is the meaning of the equivalence between two states. Yeah, Ganesh, thank you so much. Great to hear that. And guys, we never demotivate the students. Either you come to Telegram channel, or you come to Unacademy, or you come to YouTube channel. We are always here to guide you in right way. As long as you are interested, definitely you can follow this channel, and we will always try to push up to boost your energy, to boost your confidence. We are always there. And whenever you are getting the benefited and you have one responsibility, please click on like button. We at the end of our video, we only look at how many likes we get when we are putting an effort. So always we keep on informing you, please like this session, because if you like, we will automatically benefited, because everybody looks at us, and if more people are following us, definitely we will come up with a more interesting sessions in future too. Thank you so much. Thank you, Ganesh. Is it clear? If the two states are equivalent, then both should do the same job. Both should do the same job. You give me any string, either both will go to final or both will go to non-final. Is it clear? Is it clear? This is the definition of two equivalent states. Now go to this capital B, capital C. Look at, you give me any string, both will go to final. Both will go to final. Even every string no need to go to final. Some strings both can go to final. Some strings both can go to non-final. But this is a trivial one. B and C always both are going to final. Very easy to combine. Very easy to combine. Okay. Now next one, guys. Next one, distinguishable. Distinguishable. If I am saying, let's say P and Q are distinguishable. Distinguishable states. If and only if we have, there exists a string. Now we don't verify for every string. There exists a string belongs to universe sigma star, where P by reading W and Q by reading W. When you look at this, one is a final, other is non-final, and other is non-final. What is the meaning of this? Look at that. Some string in the sigma star, for some string W, from P by reading W, it may go to final. We don't know. Q and W, if it goes to non-final, that means we found they cannot be combined ever. Either this may happen, or from P by reading W. And which W? That we will look at it by using algorithm. Q and W, if it goes to final, that means we cannot combine these two states. We never combine such two states, because at some point of time they may work different because of this W. Yes. So this is what the distinguishable. And in our algorithm, our target is equivalent states, but directly you don't get it. That is the reason our algorithm follows distinguishability. In each step, we identify who are distinguishable, and in the final step, whatever we left with, they are going to be equivalent states. Now let's look at how the algorithm works. How the algorithm works. Now, without algorithm also some people can understand, but not all the time, guys. Look at, sometimes without algorithm you can understand, because here you can look at it. Q3, Q4, can you combine or not? Yes, but other than Q3, Q4, suppose Q1, Q2 may be combined, then how do you understand? That is the difficulty, guys. Remember, sometimes you can understand without algorithm, but sometimes algorithm support is required. Then I'm going to help you the DFA minimization with the help of partition algorithm. So I'm going to make the partitions in each step. Step 1, and follow me always. Step 1, and let me write something here, guys. Okay, I'm dividing into blocks, so don't worry much about it. One is this. Okay, let's start. In step 1, and by looking at this motion, we can say something. Non-final never be combined with final. Everybody knows that? Non-final never be combined with final. Yes, Adityan, it is live. Prakash, it is live. Good question. Now, 1, Q0, Q1 and Q2, these 3 are non-finals, and Q3, Q4 are finals. And why this is a partition? Why this is a partition? Because given set of states, we have divided into 2 subsets. When you do the union, you will get all the states. When you do the intersection, you will get an empty. The partition definition you will study in mathematics, discrete maths. If anything is called as a partition, if we have the subsets of given set and this subsets union, you should get the original set and its intersection should be empty. Guys, look at this. If you assume this one is one subset, this is another subset, intersection is empty, yes or no? Yes. Union, you will get all the states or not. That's why each step is called as a partition. Partition definition, guys. All right. Now come to the point. Why I made like this? Because we know the non-final states only possible to combine if they are equivalent. And you know that Q0, Q3 never be combined. Never be combined. Why? Because they are always distinguishable. How do you know that? Read epsilon. Q0 on epsilon, you will go to non-final Q0 only. And Q3 on epsilon is a final. Because Q3 itself is the final. That means we have a string always to distinguish, that is by default epsilon. So by looking at epsilon, the step 1 basically works on length of W is equal to 0. On epsilon, we are able to understand Q3 and Q0, Q3 and Q1, Q3 and Q2, they are distinguishable. Similarly, Q4 and Q0, Q4 and Q1, Q4 and Q2, these are distinguishable. Is that clear? So length, when we don't look at any length, that is 0 length, we are able to separate the Q0, Q1, Q2 from Q3, Q4. Is that clear? Step 1, everybody clear? All the non-finals keep in one set, all the finals keep in one set. Because in future, when we look at 1 length, 2 length, 3 length, and only possibility to combine which are there in the set, same set. Now, second step, guys. This is the most important one. Most important one. Entire algorithm will be decided by the step 2. And what I am going to do is Q0 I compare with Q1. And for that, I am going to maintain the database. So I am going to look at, guys, Q0 and Q1. Sorry. In future, you require, please come to this one. Q0 and Q1, there are 2 states. Look at on A what they do. On A what they do. On A, sorry, is a small 0, right? I'm sorry. Our sigma is not A comma B, it's a 0 comma 1. So I keep on changing it. It's okay. On 0, tell me Q0 on 0. Is it going to Q1? Yes. Q1 on 0, look at that. It's going to Q2. Now say that. Q1, Q2, are they in the same set? They are in same set? Yes, in same set. That means we are not able to distinguish, guys. We are not able to distinguish. So now look for the one. Look for the one, because sometimes it might happen they might be working differently on one, because we are working on length of the string indirectly 1, guys, now. Because I'm reading 0, 1 means one length is forming now. Okay, on 1. Tell me, guys, what is going to be on 1? Q0 on 1, I am going to Q2. And Q1 on 1, I am going to Q3. Now, this is how. These are already in different sets. So, we are going to separate Q0 from Q1, guys. But we don't know where Q2 goes now. and Q0, Q1 separated on symbol B, sorry, symbol 1. Everybody, and this is what we require to understand. Q0, Q1 are separated on 1 because Q1 on string 1 it goes to final, Q0 on string 1 it goes to non-final indirectly. So here no need to speak final, non-final, guys. Speak, are they going to same set or different sets? If they are going to different set, then separate them. If they are going to same set, always 0 and 1, then keep them as together now, because in future they may be separated. Everybody clear? I have separated because on 1 both are working differently. Is that clear now, guys? And in future we never need this comparison because already separated, guys. If they are not separated, we require that comparison. We require. Now look at, guys. Now Q0, Q2 I will compare Q0 and Q2. Now again on 0 find out. Q0 on 0 is the Q1 and Q2 on 0 is the Q2. Oh, 0, both are in the same set. Look at step 1. Okay, in same set. And Q0, so 1 you have to verify. Q0 on 1 is the Q2 and Q2 on 1 goes to Q4. Oh my god. Q2, Q4 are in different sets. In different sets. So now Q0, Q2 separated. So Q0 I am closing and Q2 separated. Now guys, we are in danger because Q1, Q2 are separated from Q0, but we don't know whether Q1, Q2 are same. So now we have another problem which we are not predicting now, but you have to. Q1, Q2 don't make separation. Q1, Q2 they may be in the same set. We don't know. So now we have a new challenge. Q1, Q2 we have to compare. So here on 1 these are separated. Now we have to compare Q1, Q2 and compare them, decide whether they should be together or should be separated. Now to understand that, look at what happens on 0. Q1 on 0 goes to Q2 and Q2 on 0. Look at the diagram, guys. Then only you will understand what I am speaking. Q1, Q2 on 0 coming to Q2. Yes or no? Please look at the diagram. Q1, Q2 on 0, both are coming to the same set. Everybody, please look at the diagram when I am speaking. Don't look at here and there. And they are in same set. Of course, Q2, Q2, always in same set. Nobody can separate. Now Q1 on 1, Q2 on 1. Q1 on 1 goes to Q3 and Q2 on 1 goes to Q4. Guys, Q3, Q4, are they in the same set or not? Yes, they are in same set so far. Right? They are in same set. So Q1, Q2 you should keep together. If anybody confused, please rewind the video. You will understand why did I compare Q1, Q2. Everybody, so Q1, Q2 together, guys. Keep this database in future. If Q1, Q2 are separated, this database will help you. Remember that. When they are separated, no need database. But when they are together, keep the database, because in future, when we are looking for 2 length, they may be separated. We don't know. Now we have one more comparison, guys. Q3 and Q4 we need to compare. Now guys, I'm maintaining database here. Tell me Q3 and Q4. Tell me on 0 what they are doing basically. Q3 on 0, Q3. Q4 on 0, Q3. Sorry, Q4 on 0, Q4. And Q3, Q4, are they in the same set in the step 1? Yes. So 0, okay, I'm not able to separate. They are in same set. Q3, Q4 are in same set. And now look for one, guys. Q3 on 1, Q4 on 1, Q4, okay, again Q3, Q4, again in same set. Right, same set. That means Q3, Q4 we are not able to separate. And guys, now I maintain database because when they are together, write somewhere. When they are separated, we don't need to remember further. Now The step 2, why it is so important? Because whatever you have done in step 2, same things you have to do again and again. So when you are doing again and again, you know the dynamic programming knowledge. If you are computing again and again, better to store somewhere, you can reuse next time. So I have stored these two comparisons because step 3, I'm going to look at only two things, guys. Compare Q1, Q2, already I maintained. Q3, Q4, I will compare because I have already maintained. If I look at them, I will understand what I am going to do. I will save my time. But 3, again I am looking at 0 and 1. So this is nothing but indirectly length of W is equal to, because here I have checked for 0 or 1. Here I have checked for 0 or 1. Indirectly the two length strings we are checking. In the step 3, that indirectly when you are looking for 0 or 1, we are looking at two length strings in the algorithm. That is internally hiding the concept, guys. So very less people, they understand step 3 nothing but the strings you are verifying for 2 length. Step 4, 3 length. Step 5, 4 length. Step 1, 0 length. So this is the indirect concept of the algorithm. Okay, all right, come to the point. Now guys, Q0 is same. Q0 is same because it's a one state, you can't compare with anybody. Now Q1, Q2 compare. When you compare, look at Q3, Q4 and Q2, Q2. Q2, Q2, look at in the step 2. Q2 in the same step, in the same set, and Q3, Q4 in the same set. So we have to keep together. And Q3, Q4, compare guys. Q3, Q3, Q4, Q3, Q4 in the same set of the step 2, Don't look at step 1 now. Look at step 2. That is a recent calculation. Alright. Now tell me, on 0 same set, on 1 same set. So we will have Q3, Q4 together. Now, did you identify any distinguishable pair? We have not. So we will stop the algorithm, because if you do again, you will get the same. So after verifying two length strings, you will finalize the answer. Now onwards, you will get only 3 states. That means the algorithm says that, okay, the Q0 is one set and Q1, Q2 will be combined and Q3, Q4 will be combined. Q3, Q4 are finals and Q0 on 0 goes to Q1 and same as going to Q2, doesn't matter. And Q0 on 1 goes to same. So 0, 1. Q2 is also in the same. And Q1, Q2 on 0 self loop. On 1 goes to final. And 0 on 1 final. So this is the final DFA. So 3 states in the minimum DFA, guys. Clear? Everybody clear? And really it takes time because of so many calculations. And I don't think this is required for the competitive exams point of view, but once in a while this might be really required for 2 marks. Okay, and sometimes without using the algorithm you can understand, okay, Q3, Q4 you can combine. When you combine, Q1, Q2 are doing the same job. On 1 they goes to final, on 0 both are coming to Q2. So it's very easy to understand, You can also do step by step. Everybody? Yes, come on guys. Good. Now let's practice this. Now we have one more example, guys. Are you ready to practice now? Now you have to keep the algorithm in mind because I'm not going to write anything except what I require. Okay, step 1. Keep all the non-finals in one set, like Q0, Q1 and Q2 and before applying. I forgot to tell you that. Guys, look at it. Before applying the algorithm, look at Q5. Delete it. Delete this. Why? Because unreachable state we don't need while applying the minimization. So before applying the minimization, remember this point. Here take complete DFA rather than just DFA. Complete DFA means every state is reachable from initial state. And take the DFA and apply minimization so that you will get minimum DFA. So if you keep that useless state and it will be there as it is, so you will not understand what is a minimum DFA. Is that clear? So delete those states which are unreachable. So make first any DFA as a complete DFA by delete all unreachable states from initial. So keep that in your mind, guys. Okay, so I'm deleting this first. Right? Q5 is unreachable, so I'm deleting it. So I can save my time to think about what is that. Is it clear? Now delete that. Now start the algorithm. So I saved one state. Q0, Q1, Q2 is exactly same as the previous one concept, right, guys? Previous one or not? Will apply. Quickly we'll apply now. Same or not? Okay, Q0, Q1 you apply. And you know that you can keep in mind, okay, they are working differently on symbol one, Q0 goes to Q1, Q1 goes to Q3. So Q1 is in the first set, Q3 is in another set. Okay, they are in different sets, so Q0, Q1 must be separated. So you can read yourself in mind, okay, Q0, Q1 separated. And next compare Q0 and Q2. And when I look at it, okay, Q0 on 1 goes to Q2, Q2 on 1 goes to Q4, okay, Q4 in that other set, and Q2 in this set, okay, Q0, Q2 must be separated. Okay, I separated, and Q0 is compared with all of them, close it. And now Q1, Q2 are thrown out of Q0, so you must compare them. When I compare Q1, Q2, okay, they are working same. They are going to always same set, so keep together. And then now compare. So I have compared even these two also, right? They are working same now. Q3, Q4, when I compare, okay, they looks like they are going to the same set always. Q3, Q4. And now when I compare again, whatever you have done, just look at them. And when you do that, you will get the same set. Just previously, whatever we have done, we will get the same concept. But you must be good at applying that comparisons. So finally, we will have 3 states in minimum DFA. Okay, just it's the same. Now let's practice another example. Now this is a different machine, guys. This is a different machine. Before applying, just look at, is there any state which is unreachable? Anybody? Q0 is initial state, Q1 reachable from Q0, Q2 reachable from Q0, and Q3 reachable, and Q4. Just look at like this, I can reach here, Q2, I can reach Q3, I can reach to Q4. Okay, all are reachable from Q0. Then start the algorithm. Step 1. Okay, guys. All non-finals keep in one set. Q0, Q1, Q2, and Q3. Okay, only one final, you are safe. Q4, no need to compare with anybody. Q4 is alone all the time. Okay, now step 2. Step 2 is going to be very crucial for you. Whoever has the time to understand step 2, they can easily understand step 3, step 4, step 5, and so on. Very easy to do that. And step 2, go slowly. It may take time, go slowly. Q0, Q1 compare first. Write it somewhere. Better to write it somewhere. Right? I'm just doing like that, Q0, Q1. I'm comparing. And tell me, guys, Q0 on 0, Q1 on 0. What they are doing basically? Q0 on 0 going to Q1, and Q1 on 0. Look at that, it's going to Q2. So Q1, Q2, are they in the same set? Yes, okay. So try for 1. They may be separated. We don't know, right? Try for 1. Q0 on 1 goes to Q3. And Q2 on 1 goes to Q4. Very danger. Q4 in other set, right? Q3 in this set. So Q0 on Q1, Q0 and Q1 both are differentiated on 1. String 1 you can say, because the step 2, guys. Okay, now Q0 is separated from Q1. So Q0, Q1, I'm keeping far away from that. And Q4 you can close it because that's alone always. Now Q0 next compare with Q2. Right? Now they are separated. You can delete from your database. In future, you will never compare Q0 and Q1. Remember that. Everybody, Q0 and Q1, you will never compare in the future. So you can delete from your mind your database too. But whichever are together, keep them, because in the next step, you might require to compare. Always remember what I'm trying to speak. Q0, Q2 we are comparing next. And look at what they are doing on 0 now. 0 on 0. Q0 on 0 is the Q1 and Q2 on 0. Look at that Q1. Okay, Q1, Q1, they are in the same set. But verify for 1 also. If the 1 also they are doing same, then they are always together. Q0 on 1. Q0 on 1 is the Q3 and Q2 on 1. Q2 on 1. Everybody? Come on, come on. Previously Q1, Q0, Q1 on 1 it's going to Q4. Now also same happened. Q3, Q4, Q3, Q4. They are in different set. Oh my god. Q2 also required to separate. And same symbol 1 is separated. Same symbol 1 is separated, guys. Now let's try for Q0 and Q3. Now delete from your database and Q0, Q3 we require to compare. Tell me on 0 what they are doing. Q0 on 0, Q1, Q3 on 0 is a Q2. Okay, Q1, Q2 in the same set in the step 1. Don't look at step 2 now. And on 1, Q0 on 1 is going to Q3, Q3 on 1, Q4. Again they are separated. So Q0 is alone now guys. Now Q1, Q2, Q3 we don't know whether they are equivalent or different. So we have to compare. They are right. Now Q1 compare with Q2. Now we got a new comparison. Q1, Q2 compare. Guys, compare it very quickly. Q1, Q2. It may take time. As I said, step 2, once you take time, then remaining all are very easy. Why I am comparing Q1, Q2? Because I have not done it. Q1, Q2 I was compared with only Q0. How can I believe the Q1, Q2 are different? No, right now. Okay, Q1 on 0. Guys, Q1 on 0, Q2. And Q2 on 0, Q1. Q2, Q1 are in the same set. If you are looking at step 1, okay, now go for 1. Q1 on 1, Q4. Q2 on 1 is also Q4. Then I can keep together now. So Q1 I am keeping with Q2. So Q2 I compared is over. Now maintain the database, because in future you might require to compare, and please keep it with you, because this is required in future, because again we will compare Q1, Q2 in the future, no doubt. Now next, compare another one, Q1 with Q3. Either or you can compare with Q2 with Q3, it's your choice. Q1, Q3, because now Q1, Q2 are together. Now compare guys, Q1 comma Q3. I'm comparing this one. Compare on 0. What happens? Q1 on 0 goes to Q2. And Q3 on 0 goes to Q2. Oh, Q2, both are in same set. Now similarly check for 1. Q1 on 1 goes to Q4. Q3 on 1 also goes to Q4. Okay, this identification says that Q1, Q3 always together. The reason is, you can see that algorithm, Q2, Q2 on 0, same always. Q4, Q4 on 1. So nobody can separate Q4, Q4. So I understood Q3 must be always with Q1. In future also you may compare, not a problem, but they will be always together. Now I maintain the database for you. And now guys, in the step 3, step 2 is over, right? Now look at step 3, answer is already with you, because now you are going to compare these two, you are going to compare these two, and this database already we maintained. Q1, Q2 check again. Okay, Q0 is alone, don't compare with anyone. Q4 is alone, don't compare with anyone. Q1, Q2. When I compare Q1, Q2 on 0, Q2, Q1 in the same set, you can see that in the step 2 now. In the step 2, they are in same step. They are in the same set. In same set now. And Q4, Q4 always in same set. So we will keep together. Q1, Q2 together. Now compare Q1, Q3. I just said they are always together, because you can see that Q2, Q2, Q4, Q4. Now guys, did you get the same set or same partition as the step 2? Now stop. Now answer is the 3 states in the minimum DFA. If anybody asks which states are equivalent, you can say that okay, Q1 equivalent to Q2 equivalent to Q3. because they are combined. So Q1 is equivalent to Q2, Q1 is equivalent to Q3. This is what we have understood, guys. Everybody, how many? There are 3 subsets in the step 3. That means there are 3 sets. That means there are 3 states. Clear this point? And this is what we have. And guys, in this, everybody understood the algorithm. Now let's look at equivalence classes, guys. Now let's look at the problem. L is equal to, let's say, AB. Everybody knows this problem, starting with AB. Set of all strings starting with AB, right? And the question is like this: how many equivalence classes? How many equivalence classes exist for L? L is the regular, guys. This is the regular. Every regular language, you will have few equivalence. Few means finite here. Finite number of equivalence classes. The reason is, we'll see. Can you design the minimum DFA? First target is construct a minimum DFA. Construct minimum only. Don't just design a DFA. If you just design a DFA, convert to minimum DFA. If you design NFA, convert to minimum DFA only. Okay? Construct minimum DFA, guys. What is your minimum DFA? Look at that. Starting with AB. Minimum string is AB. Minimum string is AB. Minimum string is AB. And after that, anything is accepted. A or B. And if you get anything in between, that's if I start with B or if I start with AA, then you go to dead state. This is the dead state. And how many states are there? Like, let me write P, Q, R, S. How many states? 4 states means there are 4 equivalence classes. Because whole world is divided into 4 classes. 4 classes, guys. 4 classes. Everybody clear this point? 4 equivalence classes. At least there is something to differentiate 2 equivalence classes always. Why we say P and Q are 2 different equivalence classes? Because there is a string that can separate both. Like example, if you say P and Q are 2 different classes, and from P on, let's say, B, you will go to NonFinal, and Q on B, you will go to final. That is the reason P and Q are 2 different equivalence classes. Remember that. But if it is not a minimum DFA, the P and Q can do the same job. Then you can't say 2 equivalence classes. Remember that. If you are going for the previous diagram, if anybody asking, is that Q1 and Q2, are they 2 different classes? No. Q1 and actually Q2 are in the same class. But Q1, Q2, nobody can differentiate. Because every string from Q1 and Q2, they will do the same job. So Q1 and Q2 are not equivalence classes at all. Because they are in the same class. You can't call Q1, Q2 as equivalence classes, guys. Remember, Q1, Q2, Q3 is 1 equivalence class. Here we have 3 equivalence classes. 3 equivalence classes. In the sense, Q0 is 1, Q1, Q2, Q3 is together as a 1, and Q4 is 1. There are 3 classes we have here. Everybody? Yeah, 4 equivalence classes. What is the meaning of this? The number of states in minimum DFA. Look at the definition, number of states in minimum DFA. Now you may have a question. Sir, if the language is not a regular, what will happen? What will happen, guys? For every regular, we have a DFA. For every regular language, we have unique minimum DFA. So that is the reason we have finite number of equivalences, finite number of, let's say, L, finite number of equivalence classes for L. And if it is not a regular, that we will see later. For every non-regular, we don't have a DFA. Every non-regular L, no DFA exists. No DFA, no minimum DFA, no DFA, you can say simply. No DFA, so we will have infinite number of You will never end up designing a machine. Infinite number of equivalence classes for L. So this is a very important point for you, finding the number of equivalence classes. Each state in minimum DFA is going to represent one equivalence class. Now if you look at this, what is the P represents? Let me show you one more way here. Starting with AB, right? Let me talk about that. P starting with AB. Starting with AB. Right. So let me talk about this little bit. This is a red state, right? Now what is this P represent? Basically, which is one class, here only epsilon is there. And even I can say that, let me write somehow. The P is a class. It's nothing but epsilon. And Q is another class which represent the string which comes, which halts only, that is A. A only can halt at Q. And what this R represent, that is your language, that is your L, that is equal to starting with AB. And there is another one, S. S is another equivalence class that is equal to, either you can start with B or you might start with AA. You will definitely end up with, you will end up at S only. Now guys, these are the four equivalence classes. You wanted to start with AB, that means you need to identify four classes in the world. Then only you will understand what is starts with AB. So there are four equivalence classes to understand what is L, right? What is L? If you don't want L, then complement of L you want, make PQ S R finals, then R as non-final, then you will understand complement of L. So what is the meaning here? There is much information is there. P union, Q union, sorry, let me write something here guys. There is another information is hiding. P union, Q union, R union, S, which will equal to sigma star. If I do the union of all these strings, you will get sigma star. Make all of them are final, you will get. Now do the intersection of any two. P union Q is equal to, and Q union intersection, sorry, P intersection Q is equal to Q intersection R is equal to R intersection S is equal to P intersection S, something like that. You do anything Q intersection S, which is all pi only guys. Do intersection of any two classes, any two equivalence classes, the result is always pi. And this is another information we have here. Exactly Myhill-Leroy theorem Nishu. This is what the Myhill-Leroy theorem says. I'm not saying the name, but I was teaching the same thing for you guys. This is about equivalence classes of a regular language. Equivalence classes of a regular language depends on Myhill-Leroy theorem. Okay, anyhow guys, I hope you understood the concept of the minimization of a DFA. And in this class we have learned two things: how to convert NFA to DFA, and if you want to convert NFA to minimum DFA, if you want a minimum DFA guys, you have to do first NFA to DFA, then you have to do minimum DFA, and two algorithms you have to apply. Here you need to use a subset construction, so that here you have n states. You can design with 2 power n if you want always, and here minimum DFA can prove that less than or equal to 2 power n states. Is that clear? And this is a minimization algorithm. So if anybody asks, will you get the minimum DFA when you apply the subset construction? We cannot guarantee. Is it clear? Yeah. Then we have learned what is the minimization algorithm. I have told what are the equivalence classes, and I have told equivalent states, what are the distinguishable states, and we have understood today. Yes. Yeah. Good evening, Nishu. All right. So this is what we have learned, and in the coming class we are going to learn so many interesting things like how to identify regular, non-regular, and what is the regular grammar, and what are the closure properties, and so many interesting factors we are going to learn. And stay connected with our channel. I know we have a very good benefits of the plus guys. You don't know how many educators are there, how many courses that we are going to take for you, and it's unbelievable. This plus is just like Netflix, Prime videos, and you have, once you have an entry, it looks like you have different kinds of movies you will have for the same story. Just like you will have same subject, you have different educators, you will learn different angles, so you will learn a lot from this plus subscription. And iconic, the more benefits than the plus, like you have separate study material, you will have live interaction, personal interaction with an educator, that will make you the more, you will have always motivated, and you will connected with educator, and you will learn a lot from us. And that's what I'm talking about, the plus and iconic always. And take the subscription if you are seriously preparing for GATE. Don't waste your time unnecessarily to learn randomly. We are there to help you always. And this is my profile, unacademy.com/DevaGateCSE. And this is another this is a website, devagatecse.com, where you will see all the links of my free classes in segregated manner, so you will easily access practice and regular course and guidance material, and you will find separately and segregated manner on devagatecse.com. And guys, as I said, please follow our channel and subscribe first, and share with your friends, and like, do not forget that. And remember my referral code DEVALIVE to get this subscription on Unacademy. And please let me know and how to crack the GATE exam. I'm going to help you, I'm going to guide you, and please visiting our classes. And thank you for following classes. Thank you so much. Bye bye guys, take care.